This is question 6 on chemistry from the 2014 BMAT. So we're asked, why does increasing the temperature increase the rate of a reaction? And we're asked to explain this in terms of the effects on activation energy, collision frequency, and the proportion of collisions which are successful, by saying whether they increase, decrease, or have no effect. So let's look at each of these in turn. Now firstly, what's the effect of increasing the temperature on the activation energy? Now, what is the activation energy? If we look at a reaction profile, where we have a reactant going to a product over some energy barrier, the activation energy is just the height of this barrier in terms of the energy. Now, is this affected by temperature? Well, this is actually just a property of a reaction, and so no matter what the temperature is, the activation energy is still just going to have this definite value. So there is no effect of temperature on the activation energy. Now secondly, we've got the effect of temperature on the collision frequency between particles. So what's this? Well, we've known since primary school that if we have some particles moving at a certain temperature, if we increase that temperature, they're going to start moving around more, and therefore the collision frequency is going to increase. So we know increasing the temperature will increase the collision frequency between particles, and is this going to increase the rate of reaction? Well, if they're colliding more, then they're more likely to react quickly, so this is going to increase. Now finally, what's the effect of increasing temperature on the proportion of successful collisions? Now let's think about this carefully. Is there a diagram we can draw that can sum this up? Well, what about the Maxwell-Boltzmann distribution of speeds? So we've got the number of particles of a particular speed at a certain temperature, and the energy is on this axis with an activation energy a certain distance along it. Now, how does this look if we add another line at a higher temperature? So we know it gets broader and the peak goes down, but the maximum moves to a higher energy. And notice the more particles, this is the number of particles, have the activation energy required at the higher temperature than the lower temperature. And what does this mean with relation to our question? If we have more particles with energy, at least the activation energy, then we'll have a higher proportion of successful collisions, because a successful collision means the particle must have energy that's at least the activation energy. So we can say this last one increases the reaction rate. So our final answer is that increasing the temperature has no effect on the activation energy. It increases the collision frequency, which increases the reaction rate, and it increases the proportion of successful collisions, which also increases the reaction rate. So this corresponds to answer H.